In this lesson, we are going to look at some of the characteristics of quadratic functions. So our goal is to identify the characteristics of graphs of quadratic functions. One of the first things that we can learn about is the vertex. And this is the point at which the quadratic function reaches its maximum or minimum value. It's the point where the parabola will change direction. So if we look at this example here, the vertex is located at this point. The parabola changes direction at that point, and it is also the lowest point of the parabola. Generally, a parabola will have arrows on the end, and it can continue unless it is in a situation, and then there may be restrictions. The coordinates of this vertex in this example are at the x value of 4 and the y value of 5. So the vertex here is 4 and 5. Do you see a relationship between 4, 5 and the equation of the quadratic function? And this quadratic function is written in vertex form, which hopefully you will recognize. Vertex form gives you the vertex right in the equation. Notice it is your PQ. So in any equation written in vertex form, the vertex of the parabola will be the PQ. The axis of symmetry is a line that separates a two-dimensional figure into two identical parts. For example, a parabola has a vertical axis of symmetry passing through its vertex. So if we look at this example, we have a vertical line that passes through the vertex. It acts like a mirror. The distance to the points on a horizontal line in each direction will be the same distance. No matter where you go from your axis of symmetry, the left side distance will equal the right side distance. The equation of the axis of symmetry, it is a vertical line, and all vertical lines have the form x equals. Now the x that it is equal to is the x coordinate the vertical line goes through, which in this case is 4. If you look at the equation that is written in vertex form, where does that 4 come from? Again, it is the p value. So in any quadratic function written in vertex form, the axis of symmetry will always be x equals p. We have maximum value or minimum value on a quadratic function. The maximum value is the greatest value of the dependent variable, which is the y value, in a relation. The minimum value is the least value of the dependent variable in a relation. So it's the y value that's either the lowest or the highest. In this example we have the parabola is opening upwards, so we have a lowest point. We have a minimum value. What is that minimum value? What is this y coordinate? It is 5. Where does that 5 come from in our equation? It comes from the q value. So the q value is your maximum or minimum. But which variable will tell you whether the graph is opening up or down? If you think back to the investigation that you did, you will have determined that your A tells you whether it opens up or down. If A is greater than 0, your parabola is opening up, therefore you will have a minimum value. If your A is less than 0, so if it's a negative value, the parabola is opening down, and therefore you will have a maximum value. So for this example, let's determine the following characteristics. We want to determine A, P, and Q. A is the value that is in front of the parenthesis. It is -3. P is the value subtracted from x. It is -2. Q is the constant at the end, which is +5. The coordinates of the vertex are always the PQ. So it's -2, 5. The equation of the axis of symmetry The determinant is always x equals p. So in this case, it's x equals -2. If the parabola opens up or down, A determines this. In this case, A is less than 0. Therefore, it's opening down. So if it's opening down, will you have a maximum or minimum? We will have a maximum value. Think about this. We're opening down. We have a largest point. And what is the maximum value? That is found from our Q, and in this case, our Q is 5. So the highest value is at y equals 5. Let's identify the characteristics when we are given a graph. First of all, we want the equation of the axis of symmetry. Now remember, the axis of symmetry is a vertical line that goes through the vertex of the parabola. So here is a vertical line that goes through the vertex. Because it is a vertical line, it's an x equals, and in this case it's going through the value of 4. So x equals 4. The coordinates of the vertex. So the vertex is the highest or lowest value, or the point where the parabola changes direction. This is when x is 4 and y is -16. Is there a maximum or minimum value? This is opening up. We have a lowest point, and the lowest point on the y is -16. So it's a minimum value of -16. In this example, they give us 2 points that are located on the same parabola. We want to determine the axis of symmetry for this parabola. Now, if you notice, these are 2 points that have the same y coordinates. So if we were to visualize what this is saying, at -5 and -1 there will be a point, and at 3 and -1 there will be another point. Now we do not know whether this parabola opens up or down, and it really doesn't matter. We don't know how high or how low it goes. What we do know is that those points on the parabola from the axis of symmetry need to be equal distance. So what we have to do is we have to take this distance here, we have to split it in half. Now, because we have drawn it on a graph, we can visualize it using this graph. We can count. We went 1, 2, 3, 4, 5, 6, 7, 8 units. Well, half of 8 is 4, so 1, 2, 3, 4. We should have our axis of symmetry in this spot. Let's make sure. 1, 2, 3, 4. And that is at -1. So by actually drawing it on the graph, we can count it out. If you don't want to graph it, look at your x-coordinates. We have an x-coordinate at -5, and we have one at +3. Ask yourself, how many units are between -5 and 3 on a number line? And you will know that there are 8 units. Half of 8 is 4. So moving to the right, we would have to add 4. If we were going backwards, we would be subtracting 4. -5 plus 4 is -1. 3 subtract 4 is -1. So we know that when x is -1, it is halfway between those 2 points. Therefore, that is where the axis of symmetry would be located. So in summary, a quadratic equation in vertex form. So vertex form is y equals a times x minus pl squared plus q, has the following characteristics. The coordinates of the vertex are pq. The equation of the axis of symmetry is x equals p. The parabola opens up if a is greater than 0, and it will have a minimum value. The parabola opens down if a is less than 0, and it will have a maximum value. The maximum and minimum value is q.